Hello friends, welcome to our channel. Let's have a look at problem 1352, product of the last key numbers. This is actually a very straightforward problem because the requirement is very concrete and very direct, right? So basically we have a stream. So we want to efficiently retrieve the product of the last key integers of the stream. So what we want to do is to write a class and implement two methods. One is called add and the other is called product, right? So add just appends the number to the string, and the product of integer key, put an integer key, means that we want to get the product of the last key elements. So here is some additional instructions says that there will be no overflowing, and also the product of the stream at any point in time will fit this one, right? And this is the number of calls, and essentially this item 2 and this one give us the problem size upper bound, right? So if you look at this requirement, so basically two things should come into your mind. First is that we need to use the prefix product. This is the one thing for sure. So this will yield efficiency for getting the products of last key numbers. So this is the one some consideration. Another consideration is that 0 is special, right? So if in your last key numbers there are zeros, as long as there is 0 inside the key numbers, so we should return 0. So then actually this gives us another hint, right? So if there is a 0 in the last key numbers, so it will yield product 0, right? So then how do we do this? So for this problem, for sure, we can do it in a brute force way, right? We can initialize it using a list. So as long as we have a number, we just append, and then we just get the last key numbers and then do product. But it will got time limit exceeded output. So what we can do is that besides the numbers, some or partial numbers we want to store, we can also store the number of elements. So store a counting variable. So this counting variable basically consider the most recent non-zero numbers. So if the most recent non-zero numbers is less than key, it means that we among the key most recent numbers there is at least 0, so we just need to return 0. If there are at least key numbers are non-zero, which are non-zeros, so we need to use the prefix product to get the product of the last key number. So let me quickly implement this. So here I'm not going to go over the brute force way, but I'm directly going to give you a solution with, I guess, here with O1 and OK temp complexity as in the follow-up, right? So this one work in temp instead of OK O1 there. So what I want to do here is first here self I'm going to store the product. So this will store the products of the last stream, the numbers in the stream. So here the number of consecutive non-zero elements, I'm going to store it as 1. So this n will store the number of consecutive non-zero elements. Notice that this 1 is superfluous because for multiplication 1 is the identical element, right? So once we have this, then the logic will be the following. So if we do this, so we're going to check if this current this n is greater than or equal to k. If this is the case, we use prefix product. Otherwise, we just get 0. So let me first implement this term, and then I'm going to give you a demonstration, right? So now let's see if the number you're going to add is 0. So in this case, we're going to reset this self product to be 1, and also self n to be 1, right? Just reset this one. Otherwise, so we need to self product. So we want to append. What to append? So we want to append the last element, self product last element, then times the current number, and also we are going to increment this n by 1. So now let's look at this logic. So in order to get the product, let me first check if self n is less than or equal to k. So because here we have a 1 that is superfluous, right? So if this self n is less than or equal to k, then the numbers in the stream or the consecutive non-zero elements in the stream is strictly less than k. So in this case, we just return 0, right? Otherwise, what to return? Because the way we do this, so this corresponding to the cumulative product, I would say, up to this number. And then we are going to return self product. So the product up to now, right? Then divided by self product. So -1 minus k, right? So then actually we are getting product from the last k numbers. So that's it actually for the implementation of this class. Let me first test it so that we can make sure it's correct, and then I want to explain the simple logic behind. Yeah, it passes the test case. Now let's look at generic case. Yeah, it passes very fast. So now let me give you some example. So in order to give you this, what I'm doing actually is like this. So we can consider two cases. Case 1. So let's assume k equals 2, right? Just for simplicity. So case 1. So without 0 among most recent k numbers. So what you do actually, originally your product field, let's write self product, will be something like this, right? And self n will be 1. So now I want to add a and b and c, and all of them are non-zeros. So then what I'm doing is like this, product. So we get 1. So because here I'm adding a, so I want to store 1 times a, right? And then self n is 2 now. So now if I add b, so what I'm going to have is 1. So the last element is 1 times a is a. So now what we store is 1 times a times b. Then self n is 3 now, right? So now I add c. So the product equals 1 times a, 1 times a times b. So now I have 1 times a times b times c. So self n is 4, right? So now I want to get the the product. Let's see, what's the function signature? Get product. Of the last two elements. So now I compare this 2 with this 4. 4 is strictly greater than 2. In other words, it has at least 2 non-zero elements. So what we want to do is self product the last element, that is -1, then divide by self product -1 minus this k minus that is -3, right? So then if you do this computation, right? So what we get actually is this first term is 1 times A times B times C. So if in the paper you can write this is a A1, A2, A3. It will be more clear. So now -3, this is -1, -2, -3, right? So we get 1 times A. So we just get B times C. So this is exactly what we want. So this is case 1. So so ABCs are non-zero. Case 2, with a recent 0 among most recent key numbers. Let's assume B equals 0. Now, originally you have self product. So this is just a 1, and self n equals 1. So now I have A, right? So add A. So what I get is 1 times A, and self n will be 2, right? So now add B. So add B, because B is 0. So then by our code, we are going to restore this product and n to its initial state. So what we get is actually self product equals 1, and self n equals 1. So now I add C. So because C is non-zero, so what we get is product. So 1 times C, and then self n is 2. So now let's call this one, right? Get 2. Because here 2 is the same as this one in view of the superfluous 1. So we just have one element, right, with non-zero. So in this case, we just need to return 0, right? So because this count is 2, excluding from the 1, we know there must be a 0 among the 2 most recent number. Here actually is B, right? So in general, if your key is very large, you don't know at which position there is 0 or how many zeros among the most recent key, but we don't care. As long as there is a 0, then the product for the most recent key numbers will be 0, right? That's the logic. So if you look at case 1 and case 2, actually case 2 corresponds to here, right? And case 1 corresponding to this else block. But yeah, that's the main logic. So here, if you look at the temp complexity, right? So here, for this one, this is the O1 operation, right? And for this one, we just retrieve information from indexing. This is also O1. So overall, it's O1. So in other words, it automatically addresses the follow-up for this problem. So with that said, I guess that's about it for the current problem. Thank you for watching. You are also welcome to surf on our YouTube channel, and there are more than 800 videos for leetcode problem analytics. If you find those problems useful, you can share with your friend so that we can encourage more people to practice. So with that said, that's it.